Hi everyone, this is the second video for section 6.1 on fractions. So we're just going to continue going through some of the definitions and some of the examples. Okay, so we have this notion of something being a proper fraction and something being an improper fraction. So a proper fraction is just something where the numerator is less than the denominator, and an improper fraction is everything else, right? Where the numerator is greater than or equal to the denominator. So from these definitions, we can see that every fraction will either be less than, we'll have the numerator be less than the denominator, equal to, or greater than, because those are the only three options with our numbers. So one thing to note here is that we don't want to have this notion that proper is associated with good and improper is associated with bad. We tend to kind of use these terms this way in everyday life when we're describing like kind of an action or a behavior or like manners or anything like that. But these two things themselves are not, one is not intrinsically good nor intrinsically bad. Typically, you may have your students want to work with with proper fractions and not improper fractions, but we want to get away from this idea that improper fractions are bad. They're really useful later on in math, and we don't want kids to have the ingrained idea that you shouldn't use these things because they're bad, because they're not. They just are what they are. So we have this number line that kind of compares where proper fractions and improper fractions fall. So if we're looking at a proper fraction, for example, 2/3. So the numerator is less than the denominator, which essentially means we have less parts than are in our whole. So we don't have enough to make one whole. So it makes sense that these proper fractions will kind of be right here between 0 and 1. So if we look at an improper fraction, say 3/2, well, we have 3 parts and we only need 2 to make a whole. So if we have an improper fraction, we have enough to make at least one whole with some left over. So all of our improper fractions will be 1 or bigger than 1. So just kind of realizing that there's, just comparing on a number line, there's going to be a lot more improper fractions than proper fractions, because proper fractions only live between 0 and 1 on the number line. Okay. So going along with our concept of improper fractions, we also have this concept of mixed number. So a mixed number is a number with a whole part and a fraction part. And so the reason this goes along with improper fractions is because it has more than one whole, because we have a whole part and then a fraction part, which kind of implies we have more than one whole. Similarly, with the improper fraction, we have more than one whole because our numerator is bigger. We have more parts than we need. So we can have this process of converting between fractions and mixed numbers. Improper fractions and mixed numbers. So we can write 18/5 as a mixed number. So as it is now, 18/5 is an improper fraction because 18 is bigger than 5. So to convert, we can do this division process. So we know that 18/5 has a hole in it, and we want to know how many holes are in there, how many different pieces of 5 are in here. So we divide. 18 divided by 5 is 3. And we have a remainder of 3. So we identify these two numbers. So we identify the quotient as being our whole number part. So in 18, we have 3 whole groups of 5, where we have the whole thing. We have all 5 that we need. So we have 13 whole groups of 5. So that tells us that this 3 is going to go to our whole number part. And then our remainder is going to go to our fraction part, because we didn't have enough to make a whole. We didn't have enough to make the entire whole of 5, but we had enough to make 3 out of 5. So this tells us that we can write this as a mixed number as 3 and 3 over 5. 3 wholes and 3 over 5 left over. So let's write out these steps in words that we just took. So the first thing that we did is divide the numerator by the denominator. So step 1 is divide the numerator by the denominator. The second thing is to identify what the quotient tells you. So the quotient gives the number of whole groups. And this is the whole number part. And the remainder. So the remainder is the number of pieces left over. Which is going to go in the fraction part. Okay. So one thing to note kind of with this fraction part is that this fraction part has a denominator as the divisor. Right, so the thing that we divide by, the divisor, is going to stay as the denominator, right? So the denominator started as 5 and it's going to stay as 5. So the denominator is that divisor, that number that we divided by. Okay, so we can also go the other way to write 5 2/3 as an improper fraction. So the way that we're going to do this is, so we're going to say that 5 2/3, so every mixed number really represents the value of 5 plus 2/3. Okay, so we have this kind of shortcut to convert from mixed numbers to improper fractions. So most people do it like so. Most people do it as 5 2/3. So most people do it where you multiply 5 by 3, and then you add that to 2 to get your new numerator. So if we do it in this process, 5 times 3 is 15, plus 2 is 17. So this would be 17 over 3. This is the way most people do it. This is the way most people do it. I'm really not the biggest fan of this at all. Yeah. I'm not the biggest fan of this. I appreciate shortcuts when I think that they help students understand what's going on. But this shortcut, I think, is really easy to get lost what's happening. So what's really happening is that we know that we have 5 holes, 5 holes that each are made up of 3 parts. So we want to know how many parts we have in those 5 holes, and to get that, we need to multiply 5 times 3. So we really have 15 holes, and we really have 15 parts in these 5 holes, and then we add that to the 2 parts to get 17. Okay, so like before, let's write out these steps. So the first step we do is that we multiply the whole number, right, the whole number part of our mixed fraction by the denominator. So like I said, this takes the whole number, right? We have 5 wholes and we want to know how many parts we have total. So this takes the 5 wholes, tells us that if they each have 3 parts, then we have 15 parts total in these 5 wholes. So after we do that, we know how many parts went into our wholes. We add that product from step 1 to the numerator of the fraction part. And this is where it comes in that 5 2/3 is really 5 plus 2/3. That's why we add here. 3, we set this number. We set this sum as the numerator with the same denominator as before. So right, in both of these processes where we convert from mixed numbers to improper fractions and vice versa, the denominator is going to be the same, no matter what conversion method you use. Okay, so this is a way to do it. These are ways to do it that just kind of do operations. There's also ways to represent this using models, and so we'll look at that a little bit in the next video.